This week we've been graphing systems of linear equations, and we've been getting solutions for systems of linear equations. And if you remember, there were three possible solutions that we could get when we have a set of linear equations. So if we're graphing them, one of the possible solutions we could get is just one solution, and that's if you have two linear equations that just intersect. You get one solution. It would be x comma y, whatever that x value is, whatever that y value is. Another possible solution for a linear system, a linear set of equations, would be your no solution, which would be when you have parallel lines. And the last possible solution would be an infinite amount of solutions, and that's when you have overlapping lines. So two lines that maybe overlap each other would give you an infinite amount of solutions. Today we are going to graph systems of linear inequalities and figure out how many solutions a system of inequalities have. And for the most part, hopefully you'll understand why in most cases we won't just have one solution. When we're dealing with inequalities, most cases we'll have an infinite amount of solutions. And if you remember from today, when we're graphing linear inequalities, some things that you need to remember for this lesson: anytime we have a less than or greater than symbol, remember you're going to have a dashed line. Okay. Anytime you have a less than or equal to or greater than or equal to symbol, you're going to have a solid line. Okay. Other things that you need to remember for this lesson is remember anytime it's less than or equal to, we would be shading below the line, and anytime it's greater than or equal to, we will be shading above the line. So first of all, what is a system of linear inequalities? It's two or more linear inequalities that are graphed together. And you could pause it and write this down in your notes if you need to. What is a solution to a system of linear inequalities? Well, this is the wrong graphic. I meant to put this graphic over there. But if you look at the upper right-hand corner of this slide, it's the overlapping region of points that satisfies both inequalities. So if you look at that top picture, we have two inequalities that are graphed there, and the solution would be the set where they overlap. So if we look at the two shaded regions, the solution would be this set here where we have an overlap, okay? This set right here where we have an overlap, that would be the solution. We'll do a couple examples so that you could hopefully see what I'm talking about in just a moment. So here we have two linear inequalities. So when we're graphing, or when we're trying to find the solutions of a set of linear inequalities, the first thing we're going to have to do is graph them. Luckily, these are both in slope-intercept form already, and I'm going to graph one of them with a red line and one of them with a blue line. This is number 1 in your notes. So for this first inequality, my y-intercept is going to be -1, okay, and my slope is -1. So I could go down 1, I run 1. I go down 1, I run 1, and we could go the other way as well. Okay, now if you look at this, we have a greater than symbol, right? So that means that I'm going to have a dashed line. It means I am not including the line in my set of solutions. And that kind of works the same way as an open circle would be if we were just dealing with a number line in one variable. Okay. And which side am I going to shade? Well, I have a greater than symbol, which would mean that I need to shade the side that's above my dashed number line. Okay, but this is a system of linear inequality, so I'm also going to have to graph this one. Now, you might not have the luxury of changing colors the same way I do, so you would still have to do it the same shade of pencil that you have, but I'm going to go ahead and do this in blue, so hopefully you can see visually how this looks. So here we have y is less than x minus 5, so my y-intercept this time is going to be -5, which is right here, okay? And my slope is 1. So rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Okay? So this is also going to be a dashed line because we have a greater than symbol. Now, if this was a set of linear equations, my solution would just be this point right here where they intersect. But this is not a set of linear equations. This is a set of linear inequalities. So my solution is going to be where both inequalities overlap, where both solution sets of each inequality overlap. So let me show you what I mean by that. Give me one moment. So this right here was a less than, so that means I'm going to be shading below the line, which is right over here. Now take a look at what happens here. Here, if I look at this set of inequalities, I have a section where I have both blue and red. I have a section where both of my inequalities overlap. So what would the solution of this set of linear inequalities be? It would be just this section right here, which I'm going to do in a different color. I'll go ahead and do this in black so you can see it very clearly. This section right here, where they both overlap, just this section right here. That would be the only solution set that would satisfy both inequalities. Just this section right here. Not this section, not this section, just the section where they overlap. Let's do another example so hopefully this starts getting a bit clearer to you. So here we have two more sets of inequalities. What I'm going to want to do first is change them to slope-intercept form, and you should be familiar with how to do that already. So that would be, for the first inequality, we'd have 4y equals negative 6x plus 12. And if we divide both sides by 4, we get y equals negative, let's see, that would be negative 3 over 2x plus 12 divided by 4, which is 3. Okay, and I did this quite rapidly, but the reason why I have 3 halves as a slope is because when we divide by 4, that would have been negative 6/4, and that would simplify to negative 3 halves. I apologize for doing that quickly. So for my next inequality, if I change it to slope-intercept form, I move the 3x, that would be negative 4y is greater than negative 3x plus 8. And if I just divide both sides by 4, that would give me, by negative 4, that would give me, well, because I'm dividing both sides by negative 4, I must flip the inequality symbol. So it would give me 3/4 x minus 2. So if I'm graphing these, I'm going to graph them the same way that we did today. And you guys did awesome on this today. So for my first inequality, the red one, my y-intercept is going to be 3, which is right here. And then my slope, I'm going to rise, or I'm going to go down 3 because it's negative 3 halves, and I'm going to run twice. Okay, down 3, run twice. Okay, and I could go the other way as well. Now for this one, I have once again I'm sorry, I put an equal sign here, but this should have been the greater than symbol. I apologize for that. I have a greater than symbol, so that means I'm going to have a dashed line, which means I'm not including the line in my set of solutions. Okay, and which side am I going to shade? Okay, it's a greater than symbol, so I'm shading above the line, and this is nothing new. This is what we did today. This is what we did today, and you guys did awesome with this. I'm just shading above my line because it's a greater than symbol. What's different is now I'm going to also put this inequality in my graph, and I'm going to see where they overlap. So I'm going to use blue for this, and my y-intercept is negative 2, so it would be negative 2 right over here, and my slope is positive 3, so rise 3, run 4, which is right here. Rise 3, run 4, which is right here, or I go the other way as well. Okay? And what kind of line am I going to have? It's a less than symbol, so I'm going to have a dashed line as well. This is everything that we did today, nothing different. The only difference is when I'm looking for the solutions of the set of inequalities, I want to see where they overlap. So this is a less than symbol. That means I'm going to shade below my number line. What is the solution to this set of inequalities? Well, it's the section that overlaps. So if you look at the set of inequalities, where do the solution sets overlap? It would be where I have both red and blue. Okay, and you don't have different colors that you're going to be using, so you would just have to see, well, which one has both sets of solution. And then what you could do, since you don't have different colors like I do, is you could just put like an S here, and that would mean, hey, that's this section here is a solution. But I'm going to go ahead and shade the whole thing black, just because I do have different colors. That way you can really see what that solution set is, and hopefully it's a bit easier for you to recognize the solution set. But in your own work and on your own tests and your own assignments, you would just put an S where the solution set is. So now this one's going to be interesting, so let's go ahead and solve this one. Go ahead and pause the video and solve for y. You should know how to do that already, so solve each of these equations for y so that we have them in slope-intercept form. So if you did that, you should have gotten y is greater than negative 2/5 x plus 4, and y is less than negative 2/5 x minus 5. So what do you notice here? I mean, our slopes are the same, our y-intercepts are different. So hopefully you remember what that means from a couple chapters ago. That's going to mean that we're going to be dealing with parallel lines. And we did that with a system of linear equations, remember, and that was our no solutions. So let's see what happens when we have inequalities instead of equations. So let's graph the red one first. The red one is going to have a y-intercept of 4, right? Which is going to be right here. And your slope, we go down 2 and to the right 5, which is right here. Down 2 and to the right 5, which would be right here. And we go the opposite way as well. Okay. And what kind of line am I going to have? Unfortunately, all my examples have been dashed lines. I should have included ones that have solid lines. But we're going to have a dashed line once again because it's a greater than symbol. Okay? And what area am I going to shade for my red line? Well, it's a greater than symbol, which means I'm going to shade above my line. It's going to look like this. I'm going to shade above my line. Okay, now for my blue, my y-intercept is going to be negative 5, which is right here. And the same slope. So I'm going to go down 2 to the right 5. Down 2 to the right 5. And I could go the other way as well. Okay. And once again, I'm going to have a dashed line. So parallel lines here. I have parallel lines. And for my blue one, it's a less than symbol, which means I'm going to shade below the line. So what would the solution of this set of linear inequalities be? Well, if you look at it, we're not overlapping at all, right? So think back to linear equations when we didn't have any point where they intersected. We had no solution. So here we have no point where they overlap. So we're going to have no solution. Are we always going to have no solution with linear inequalities? Well, with linear equations, we always had no solutions when we had a set of parallel lines. That's not always going to be the case with linear inequalities. This one would have no solution, but let's take a look at one that will have some solutions. So again, pause the video and solve both of these for y so that we could have both of them in slope-intercept form. Hopefully you remembered to flip your inequality symbols when you divided both by a negative, both sides of the inequality by -1 or negative. So if you look at this, our slopes are the same again. So these are going to be parallel lines. But let's see if we're going to get a no solution here. So our y-intercept for the red one would be -6, right? Which would be right here. That's 5, I'm sorry. That's where -6 would be. My slope is 3, so I'd rise 3, run 1. Rise 3, run 1. Rise 3, run 1. And again, for some reason, all of my examples today are dashed lines. I'm sorry about that, but hopefully you know that if you had a greater than or equal to sign, in fact, let's change that to greater than or equal to. That way we have and let's change both of these. That way we have some examples that have a solid line. We're going to have a solid line if it's greater than or equal to, which would mean that we are including the line in our solution set. And that's our red. That's our red inequality. Now, what side am I shading for my red inequality? Well, it's greater than or equal to, which means I'm shading the side above the line, which is this side right here. Okay. Now, for blue, we have y is less than or equal to 3x plus 2. So my y-intercept is 2, which is right here. And I'm going to rise 3, run 1. Rise 3, run 1. Okay. I go the other way as well. And this is going to be a solid line. So we have parallel lines. Okay. I hope you could already start seeing that this is going to be a bit different than our last example of parallel lines. For my blue, it says y is less than or equal to 3x plus 2. So I'm actually going to be going below the line. So am I going to have solutions for these sets of parallel line? Yes. If you see, if you look at this, we have a section where they overlap where I have both red and blue, and that's going to be this middle section here. That's going to be my solution set for this system of linear inequalities, okay? So I think this video is under 15 minutes. There you go. We'll talk more about this tomorrow. See you tomorrow.